Okay. Good evening, everyone. Welcome to this live session, which is basically based on the course content of week 9 of this NPTEL course on fluid mechanics. Yeah. Now, if you have gone through the lectures of week 9 of this course on fluid mechanics, then you must have understood that the week was dedicated to the conservation of mass and stream functions basically, and a little bit related to the derivation of Navier-Stokes equation. It was started. So we'll try to solve some problems on this course on fluid mechanics that is relevant to week 9. Yeah. So let's move to the first question. For the values of phi for different flows, okay, values of phi for various flows are given. If you determine the corresponding values of psi, so what is phi? Phi is velocity potential function, and what is psi? Psi is stream function. Now, what is the relationship between phi and psi and the velocity field? For 2D flow, we know that u is equal to del phi by del x, v is equal to del phi by del y, where phi is the velocity potential function. And what is stream function psi? Stream function psi is a scalar function such that v is equal to del psi, v is equal to del psi by del x, sorry, v is equal to del psi by del x, and u is equal to minus of del psi by del y. Okay. Now, if psi exists, then these components of u and v are such that they satisfy Cauchy-Riemann equation. Okay. Now, in the given problem, for different flow situations, the values of phi's are given to you, and from the values of phi, you need to find the values of psi. Okay. From the value of phi, you need to determine the value of psi. Okay. So let us take the first problem, problem 1, that is phi is equal to 3xy. Okay. So in the given problem, what is the value of phi? Phi is equal to 3xy. Okay, phi is equal to 3xy. Now, if phi is equal to 3xy, what will be the value of u? U will be del phi by del x. Okay, u is del phi by del x. So, del phi by del x is basically 3y. And what will be v? V will be del phi by del y. And what is del phi by del y? In this case, for this function, it will be 3x. Okay. Now, u is equal to what? U is equal to is equal to minus of del psi by del y, and v is equal to del psi by del x. Okay. Now, this is say our equation 1, and this is say our equation 2. Now, what is psi basically? Psi, if you take equation 1, what will be psi? If you take equation 1, psi will be equal to what? If you look carefully, psi will be equal to minus of integration minus of u delta y. Okay, means u is a means u may be a function of both x and y, but we are integrating with respect to y only. Okay. So what is the value of u? The value of u is 3y. So minus of integration 3y del y. So what will be the value of this? The integration of this will be minus 3y square by 2 plus some constant of integration. Okay, say I am calling it c1. Now since this is integration only with respect to y, so any function of x is also a constant. Okay, you can check it. If you do del psi by del y, if we do del psi by del y with a minus, okay, what will you get? Del psi by del y, this part will entirely vanish. This part will vanish entirely because it is a function of x. So del psi by del y will be 0. And here what will you get? Minus of 3 by 2 into twice y is minus of 3y, but u is equal to minus of del psi by del y, so it will be 3y finally. Hence it is verified. So from this equation, from the u component, psi is equal to minus of 3 by 2 y square plus c1x. Now similarly, if you take the other equation, that is equation number 2, from this what will be the value of psi? Value of psi will be integration of 3x delta x, okay, and this will be 3 by 2 x square, okay, 3 by 2 x square plus c2, which is, it may be a real constant or it may be some function of y, okay, because we are integrating with respect to x. Now c1x and c2y, if you look at the values of c1x and c2y, okay, so psi from one part is minus of 3 y square by 2 plus some function of c1x, okay, and from the other lookout it is 3x square by 2 plus c2y, okay, that we have seen here. Means there are two expressions, okay. So one expression gives the value of psi as minus of 3 y square by 2 plus some function of x, and the other expression gives us the value of psi as 3 x square by 2 plus c1y, okay. So what is the actual value? What is the actual value? So here you need to make some judicious some judgment, okay. So based on the judgment, so this is say the value of psi, say I am saying psi 1, and this is say the value of psi is psi 2. Now c1x is a function of x, is this. c1y is a function of y, so it is this. So psi may be considered as 3 by 2 x square minus y square. So this is a possible value of psi, okay. So this is the first problem, okay, this is the first problem. Now v is equal to minus of del psi by del x. So see, in this case, uh, why it is slightly different from what we have done here? It is slightly different because you can either choose v as del psi by del x and u as minus of del psi by del y, or you can choose v as del psi by del x and u as minus of del psi by del y. Now if you look carefully, what we have taken, we have considered that u is equal to minus of del psi by del y. So rather than, so it will not make any difference, okay. Only in the functional form the difference is there, and there is some constant, okay, there will be some constant c. Okay. Now let us move to the second part of this problem. Phi is equal to 4 x square minus y square. Now u is equal to del phi by del x. So if you differentiate phi with respect to x, this part will be 0. So it will be 8x. Okay. And this is equal to del phi by del y. Okay. Hence, if you integrate this equation del phi by del y equal to 8x, you will be getting 8xy plus some function of x, because we are integrating it with respect to y. So the first expression of psi is this. Psi is equal to 8xy plus fx. Now what is v? V is del phi by del y. Del phi by del y is minus of 8y, which is equal to minus of del psi by del x. So from here, what will be the value of psi? The value of psi will be minus of, see, minus of 8y is equal to minus of del psi by del x. Okay. So minus of 8y is equal to minus of del psi by del x. So what will be psi? Psi will be 8xy plus some function of, okay, we're integrating, so some we are integrating with respect to x, so it will be some function of y. Okay, 8xy is some function of y. Okay, now we can see that in both these expressions 8xy and 8xy are common. Okay, 8xy and 8xy are common, so 8xy plus c. Similarly, in the next part, phi is equal to x plus y plus 3. So u is del phi by del x. So it will be 1, which is equal to del phi by del y. So from here, psi is equal to y plus some function of x. V is del phi by del y, which is also 1, which is equal to minus of del psi by del x. So psi will be minus of x. Okay. So it is minus of x plus y minus of x plus y plus c is the value of psi. And similarly, so these are the three problems. So the question may be asked in the reverse direction also. It means that the values of psi, that is the stream functions, might be given to you, and you may be asked to determine the value of potential function from stream function. But what is important is you should always remember, okay, you should always remember that u is equal to del phi by del x, v is equal to del phi by del y. Okay, in some standard textbook you might find it u is equal to minus del phi del x, v is equal to minus del phi del y. That is also fine, but if you are using minus, then you should use minus for both the components, and if you are not using minus, then it should be plus for both the components. Okay, similarly u is equal to del psi by del y, v is equal to minus of del psi by del x. Okay, or you can use another form where u is equal to minus of del psi by del y and v is equal to plus del psi by del x. So that is your wish, or whatever standard books you are referring to, that is fine. One important thing or aspect related to this phi and psi is, if phi exists, if velocity potential function exists, then the flow is irrotational. Okay, if it exists, then the flow is irrotational, and if it satisfies Laplace equation, okay, and if it satisfies Laplace equation, that is del 2 phi equal to 0, then it is a possible case of steady, incompressible, and irrotational, definitely, because phi exists means flow is irrotational. Apart from that, if it satisfies Laplace equation, then it is a case of steady, incompressible, irrotational flow. Okay. Similarly, if psi exists, then the flow may be rotational. Okay, the flow may be rotational or irrotational. Okay, if psi exists, flow may be rotational or irrotational. But if it satisfies Laplace equation, that is del 2 psi equal to 0, then it is a possible case of irrotational flow. Why? Because if you look at the rotation vector omega, okay, if you look at rotation vector omega, then all the components. Okay, for example, what is omega z? Okay, for a two-dimensional flow, what is omega z? Omega z will be half of, okay, okay, now half of, what is del v del x? Del v del x, v is what? Say we are writing v as del psi by del x, and what is u? U is minus of del psi by del y. So what is del v del x? Del v del x is del 2 psi del x square, and what is del u del y? Del u del y is minus of, so this two minus will become plus del 2 psi del y square. Okay, now if there is no rotation, then this is basically omega z, this will be 0, and if this is 0, then we can see that del 2 psi del x square plus del 2 psi del y square, for this always to be 0, this particular part should be 0. Okay, and this is what? This is equal to 0 is nothing but the Laplace equation, that is del 2 psi equal to 0. Okay, so if it satisfies Laplace equation, then it is a possible case of irrotational flow. Let us move to the next problem. Okay, for the following functions in two-dimensional irrotational flow, it is given to you that the flow is two-dimensional, okay, and irrotational. Okay, determine the conjugate functions. You have to determine the conjugate functions. Conjugate function means psi is given, you need to determine phi, that is the velocity potential function. In the second part, phi is given, okay, that is the velocity potential function is given to you, you need to compute the stream function. Okay, let us look at the first part. Now one more important thing, you can see that both these functions, the stream function in the first part and the velocity potential function in the second part, they are not in our standard Cartesian coordinate or xyz coordinate system. They are in polar coordinates or radial coordinates. Okay, so in radial coordinates, the radial component of velocity Vr is del phi by del r, okay, which is equal to 1 by r del psi by del theta. Okay, so it is basically the r theta coordinate, and the v theta, okay, v theta or the angular component of velocity is 1 by r del phi by del theta, which is equal to minus of del psi by del r. Okay, now for part 1, psi is equal to m ln r. Okay, now Vr is equal to 1 by r del psi by del theta. Okay, so what is del psi by del theta? There is no dependency of psi on theta, so del psi by del theta is 0, and which is equal to del phi by del r. So what will be phi? Phi is basically a function of, if you integrate this, it is basically a function of theta. And what is v theta? V theta is 1 by r del phi by del theta. It is 1 by r del phi by del theta. Okay, it is 1 by r del phi by del theta. So 1 by r, what is del phi by del theta? Del phi by del theta is f dash theta, which is equal to minus of del psi by del r. Okay, so the value of psi is given. What is del psi by del r? M by r minus of m by r, because it is with a minus sign. And what is d dr or del r of m log to the base e r? It is m by r. So f dash theta is equal to minus m, and hence f theta is equal to minus of m theta plus c, where c is a constant, and hence the value of phi is equal to minus of m theta plus c. Okay, so in this particular question, the procedure is similar to the question that we have solved, okay, the first problem, but the only difference is the coordinate system. Here the expressions of psi and phi are given in the radial coordinate system, and for radial coordinate system, Vr and V theta, Vr is del phi by del r, V theta is 1 by r del phi by del theta, and Vr is 1 by r del psi del theta, and V theta is minus of del psi by del r. Okay, so using this expression and following a similar procedure as we have done in question 1, you can get the value. Okay, so based on this, I am giving you 5 minutes, okay, and you please try the second problem, that is phi is equal to m cos theta by r. So those who have joined just now, we are solving problems related to stream function and equipotential functions. Okay. For this particular question that is on your screen, we have already discussed the solution to the first part of this problem, that is when the value of psi is given as m log to the base e of r, that is in the radial coordinate system, how to determine the value of phi. And following a similar procedure, now we are looking, means we've been given 5 minutes of time so that you can solve the second part of this problem, where the value of phi, that is the equipotential function, is given, and from that you need to find the value of psi. Okay, so let us look at the solution. So just as we have done in the first part, that is psi equal to m log of r. Here also the relationship between vr and v theta okay, VR is del phi by del r, okay, and which is equal to 1 by r of del psi by del theta, and V theta is 1 by r del phi by del theta, which is equal to minus of del psi by del r. Okay, so for phi equal to m cos theta by r, that is the expression which is given to us. Okay, and for that we need to find the value of psi. So phi is equal to m cos theta by r. So VR is del phi by del r. Okay, now if you differentiate this phi with respect to r, what you will be getting? M cos theta by r square, but there will be a negative sign which is missing here. Okay, there will be a negative sign because it is r 1 by r, so r to the power minus 1, so minus m cos theta by r square. Okay, and this is equal to 1 by r del psi by del theta. Okay, now if this is 1 by r del psi by del theta, what will be del psi by del theta? Of course, including the negative sign, it is m by r cos theta. Okay, and if you integrate this with respect to theta, it will be what? Okay, it will be what? It will be m by r sin theta plus some function of r. Now see, psi for this particular case in the radial coordinates, okay, in the radial coordinates, psi and phi are functions of r and theta. Okay, so when you are integrating this with respect to theta, okay, so the constant may be a real number, okay, it may be a number or it may be a function of r. Okay, so that is the only difference. So psi is equal to m by r sin theta plus fr. Okay, now what will be v theta? V theta is minus of del psi by del r. So we have already obtained the value of psi. So minus of, now if you differentiate this with respect to r, so minus of m by r square sin theta minus of f dash r. Okay, so this is the value of minus of del psi by del r. Okay, now again in the differentiation there will be a negative, so you please include that. Okay, now v theta is 1 by r del phi by del theta. So that is from the definition of v theta or the dependency of v theta. Okay, or the definition of the equipotential function in the radial coordinate system. So v theta is 1 by r del phi by del theta. So 1 by r, what is del phi by del theta? Del phi by del theta is, you have already seen, the value of phi is known to us, so del phi by del theta you can very easily compute, and the value of v theta is minus of mr square sin theta. Okay, now using this particular expression of v theta, okay, of v theta in this equation, okay, in this part, what you will get? You will get the value of f dash r, which is minus of 2m r square sin theta. And what will be fr? Fr, you simply need to integrate this. Okay, you simply need to integrate this, but with respect to r only. Okay, so that will give us the value of fr as minus twice m by r sin theta plus some constant c. So the value of psi for the given value of phi is m by r sin theta minus of twice m by r sin theta plus c, and psi is equal to minus of m by r sin theta plus c. Okay, so what is the general procedure for finding this? The general procedure is very simple. Okay, we know what is the dependency. Okay, so let us discuss this in in Cartesian coordinate system. We know that u is equal to del phi by del x. Okay, and we know that v is equal to del phi by del y. We also know that u is equal to minus of del psi by del y, and v is equal to del psi by del x. Okay, so these four relations are known to us. Now suppose the value of phi is given to you. So if the value of phi is given to you, okay, you can easily find the value of u and or the expression of u and the expression for v. Okay, once you have the expression for u and expression of v, you can find the value of psi. Okay, either using u or you can use the expression for v for determining the value of psi. Okay, suppose you have obtained the value of psi using the expression for u. Okay, suppose you have used the expression for u, okay, and you have obtained the value of psi. Okay, then psi is equal to what? Psi v is equal to minus of del psi by del x. Okay, so what you do? V, the value of v is already known from the value of phi. The expression for psi you have already obtained from this u after integration. So you simply differentiate it with respect to x. You use this expression to determine the value of the constant. Okay, the integration which may be a function of x or a function of y. Okay, so that will give you the final answer. And similarly, if the value of psi is given, you have to follow a similar procedure and you have to obtain the value of phi. Okay, so this is the problem. Now let's move to the next problem. Consider a two-dimensional incompressible flow in cylindrical coordinate system. Okay, the tangential velocity component is u theta equal to k by r, where k is a constant. This represents a class of vertical flows. Okay, so consider a two-dimensional incompressible flow. The flow is two-dimensional. Also, the flow is incompressible in cylindrical coordinate systems. Okay, so in cylindrical coordinate system, see, in radial coordinate system we have r and theta. In cylindrical coordinate system we have three coordinates r, theta and z. Okay, where the tangential component of velocity is u theta equal to k by r, where k is a constant, and this represents a class of vertical flows. Okay, means vortex flow. You have to generate an expression for the other velocity component ur. Okay, so in the given problem, the expression for u theta is given, which is equal to k by r, and you need to find the value of ur. Okay, you need to find the expression for ur when it is given that the flow is two dimensional and incompressible. Okay, so let us look. For a given tangential velocity component, we have to generate an expression for the radial velocity component. Okay, so the tangential velocity component is given to you. You need to determine the expression for radial velocity component. The flow is two dimensional. Okay, the flow is two dimensional. Now, since flow is two dimensional, though in cylindrical coordinate it is r, theta and z, but in the question it is given that the flow is two dimensional, so we are neglecting the z coordinate, so it is only r and theta, so it is equivalent to a radial coordinate system. Okay, in the xy or the r theta plane, velocity is not a function of z and uz is 0. Okay, so basically, ideally for r theta z there are three components, which is ur, u theta and uz, but since in the question it is given that the flow is two dimensional, we are considering that this component is 0. Okay, now since this component is 0, the only thing that you need to determine are ur and u theta. Okay, the incompressible continuity equation means the continuity equation for incompressible flow in radial or cylindrical coordinate system. Okay, when we are neglecting the z direction, it is 1 by r del r of r u r plus 1 by r del u theta by del theta equal to 0. Okay, or you can rearrange this as del r of r u r is equal to minus of del u theta by del theta. Now the given expression for u theta, if you look, the expression for u theta is given. The given expression for u theta is not a function of theta. U theta is equal to k by r, where k is a constant. So u theta is basically a function of r only. So if u theta is not a function of r, then this particular expression or the partial derivative which is on the right hand side of equation 1, it will also vanish. So simply you are left with del r of r u r equal to 0, and if you integrate this with respect to r, you will be getting r u r is some function of theta and time. Okay, if you consider unsteady flow process. Okay, now if we solve for ur, what will be the value of ur? F theta t by r. Okay, so this is the value of f theta t by r. Okay, so it is always advisable to follow a problem. Okay, if you start a problem from the very basics. Okay, so for this problem, you first of all need to determine whether you need to make use of the momentum equation or the continuity equation or the energy equation. Once you have decided that, you write the most general form, okay, for the coordinate system that is under consideration, and after that, based on the assumption, you try to reduce the number of terms. Okay, so that way though at the beginning it may look a little bit lengthy and tedious, but it will give you more confidence, it will give you a better understanding, and you will be able to means the chances of error will be or mistakes will be less. Okay, now let's move to another problem. Two velocity components of a steady incompressible three-dimensional flow field are namely u is equal to ax square buy square plus cz square and w is equal to axz plus byz square, where a, b, c are constants. The y velocity component is missing. You have to generate an expression for y, that is the y component velocity, that is v, as a function of x, y and z. So in the given problem, what has been asked of you, there is a flow field, okay, v, three-dimensional flow field u I cap, v j cap, w k cap. Okay, now out of these three components, the expression for u and w are given. Okay, so u is a function of x, y, z and t. Similarly, w is a function of x, y, z and t. Okay, but in the question it is given that the flow is steady. Now if it is steady, there is no dependency on of these velocity components on time, so time is not there. So finally what you can write, we can write that u is a function of x, y, z, and similarly w is a function of x, y and z. Okay, now the expression of u is given, which is ax square by square plus cz square, and expression of w is also given, which is axz plus byz square, and you need to determine the expression for v, and it is given that a, b and c are constants. Okay, so a, b and c are constants and you need to generate an expression of v in terms of x, y, z. So please take 3-4 minutes and see how you can solve this problem, then we will discuss the solution. Okay, let us discuss the solution. Sorry. We need to obtain the y component of the velocity v using the expressions for u and w. And what are the assumptions? The assumptions that are given to us is that the flow is steady and the flow is incompressible. Okay. Now, what is the continuity equation for incompressible flow? The continuity equation for incompressible, okay, plus the flow is steady. So for steady incompressible flow, it is del dot v equal to 0, that is the divergence of velocity field is equal to 0, or in Cartesian form del u del x plus del v del y plus del w del z is equal to 0. Okay, now what is the expression for u? Expression for u is ax square by square plus cz square. Ax square plus by square plus cz square. Okay, so what will be del u by del x? Del u by del x will be twice ax. And what is the expression for w? Expression for w is axz plus byz square. Byz square. So del w del z will be what? Del w del z will be ax plus twice byz. Okay, now del u del x. Now from the assumptions that is the flow is steady and incompressible, from that the continuity equation is del u del x del v del y plus del w del z is equal to 0. So it gives us del v del y is equal to minus of del u del x plus del w del z. Now we have already obtained the expressions for del u del x and del w del z. So what are those? So based on those, what will be the value of v? Del v by del y, del v by del y is minus of 3ax. Okay, so we have already found the value. Okay, twice ax plus twice byz. So 3ax plus twice byz. So minus of 3ax minus of twice byz. Okay, now next, in order to find the value of v, we need to integrate with respect to y. So since the integration, it is a partial integration of, okay, so we need to add some. Okay, so if it is a partial integration, the constant of integration may be any function of x and y including a real constant. Okay, so v, what will be the integration of this? Minus of 3axy minus of 2bz y square by 2. So 2 and 2 will cancel out. So bz y square plus some function of x and z. Okay, now any function of x and z yields a v that satisfy these incompressible equations, since there are no derivatives of v with respect to x or z in the continuity equation. So it means that you put any function of x and z, it will satisfy in this expression of v, it will satisfy the flow for the given situation. So in order to determine the a specific value of f of x and z, you need to have some other constraint or some other condition. That is very important. So I hope this question is clear. So here also you can see that what has been the approach. The approach is we have taken the general form. Okay, so we first of all, looking at the question only, one can very easily make out that we need to make use of the continuity equation, and then if you write the full form, then after applying the assumptions that is the flow is steady and incompressible, you simply write the continuity equation for steady incompressible flow. Then you utilize the data or the information that is given to you in the question, and then a simple integration will yield the result. Okay, so I hope this is clear. Now let's move to the next problem and the last problem of today's session. A steady two-dimensional incompressible flow field in the xy plane has a stream function given by ax cube plus by plus cx, where a, b, c are constants. Okay, and the value of a is 0.5 meter per meter per second, Okay, B is equal to minus 2 meter per second and C is minus of 1.5 meter per second. Okay, so in the first part you need to obtain the expression for the velocity components u and v. Okay, you have to verify that the flow satisfy the incompressible continuity equation. Okay, so for completing the second part, that is to verify that the flow field satisfy the incompressible continuity equation, you must obtain the u and the v components. That is what has been asked in the first part. Okay, so second part depends on the solution of the first part, and in the third part you have to plot several streamlines of the flow in the upper right quadrant. Okay, in the upper right quadrant. Okay, so there is a two-dimensional flow which is steady as well as incompressible, and for that flow, okay, nothing has been mentioned related to whether the flow is rotational or irrotational. It has been given to you that it is a steady two-dimensional incompressible flow. Okay, and the stream function is ax cube plus by plus cx. Okay, so psi is basically a function of x and y. The values of a, b and c, which are constants, are given to you. Okay, you need to obtain the expression for velocity components u and v. That is the first part. Then utilizing these velocity components, you need to show that the flow field satisfies the incompressible continuity equation, and in the last part you need to plot several streamlines of the flow in upper right quadrant. Okay, I'm giving you a few minutes so that you can check whether you have understood the problem or not, and you please try the problem and then we'll discuss the solution. Okay, so let us discuss the solution to this problem. So the stream function, for a given stream function, we need to calculate the velocity components we have in the first part. The second, we need to verify the velocity component satisfies the steady incompressible continuity equation, and in the third part we need to plot the streamlines. Okay, so what are the assumptions that are given in the question? The flow is steady, two-dimensional and incompressible. Okay, so the assumptions are the flow is steady, the flow is incompressible, and the flow is two-dimensional in the xy plane. Okay, so there is no z component of velocity, that is w equal to 0, and further u and v depends only on x and y, not on z. Okay, so the value of stream function psi is given to us. Now what is the dependency of psi, or the relation of psi with u and v? U is equal to minus of del psi by del y. Okay, and v is equal to del psi by del x, or alternately we can use this form: u is equal to del psi by del y, and v is equal to minus of del psi by del x. Okay, now the value of psi, or the expression for psi, is given. So what is the expression for psi? It is ax cube plus by plus cx. Okay, so what is u? U is del psi by del y. So if u is del psi by del y, first of all let us write the expression for psi. So the expression for psi is ax cube plus by plus cx. Ax cube plus by plus cx. Okay, ax cube plus by plus cx. So u is equal to del psi by del y. U is equal to del psi by del y. It means that if you differentiate this expression of psi with respect to y, what will you get? B. Okay, you will get B. You will get B. Similarly, V is equal to minus of del psi by del x. So minus of del psi by del x minus of 3a x square plus c. Okay, so minus of 3x square, oh sorry, it will be minus of c. Yes, it will be minus of c, because it is minus of del psi by del x. Okay, now since u is not a function of x and v is not a function of y. Okay, now from the given expression we can see that u is basically equal to a constant. Okay, so it is not a function of x and v is not a function of y. We immediately see that the two-dimensional incompressible continuity equation is satisfied. How? Okay, you have already obtained the expression for u and v. Okay, we have already found the expression for u and v. That was the first part. Next is the continuity equation. Okay, so u is equal to v and v is equal to minus of 3ax square minus of c, minus of 3a x square minus of c. Now what is del u by del x? Del u by del x is 0 because b is a constant. What is del v by del y? Del v by del y, you can see that v is not depending on y, so this is also equal to 0. So for two-dimensional steady incompressible continuity equation is del u del x plus del v del y should be equal to 0. So we can see that del u del x is 0, del v del y is 0. So this expression is satisfied. Hence the second part of the problem, that del u del x plus del v del y should be equal to 0, that is also complete. Okay, so the flow is indeed incompressible. Next, in order to plot the streamline, we solve the given equation. Okay, you solve the given equation either for y or for x. Now looking at the expression, okay, in terms of x it is raised to the power of 3. So it is easier to convert this equation in terms of y. So y is equal to psi minus ax cube minus cx by b. Okay, so for different values of x, okay, for different values of x, you will get different values of y. Okay, for a given psi, because the value of, see, psi is what psi is. Okay, for several, you choose a value of psi for a given value of psi. Okay, you, for different values of x, you'll be getting different values of y, and based on that, if you plot it in the upper first, means in the first quadrant, okay, in the first quadrant, basically you'll be getting something like this. Okay, so this is all for today's session. I hope the problems have further clarified your concepts and you need to solve some more problems. There are ample problems available on these topics on potential function and stream function in standard textbook. Now, this particular week, there are also some content related to conservation of mass, but we have uh, exhaustively covered the problems related to conservation of mass in our previous live sessions. So that's why I have intentionally kept all the problems in today's session related to the stream functions and velocity potential functions. So we'll again meet next week with some problems related to the content of week 10. Let's stop here. Thank you.